Oh, hey, what's up, everybody? Welcome back. We're now in Unit 2, so that's good news. All right, we're actually doing this pre-calculus 12B. Happy to have all of you watching this video. Let's do this. So first of all, okay, reciprocal and rational functions. For the first week or so, we're going to focus on reciprocal functions only. And I would say that we are probably beginning with the most difficult part of this unit. So we're just going to rip off that Band-Aid. We're just going to get to it right away. And then I feel like everything else we do in this unit after the first few days should be much easier. So not trying to scare anyone, just kind of letting you know, this is we're going to do the most difficult stuff first. Maybe not this particular video. Maybe it's the next one. All right. Right now we're just doing a look at the introduction to reciprocal functions. Basically, just exploring the concept of reciprocals and taking a look at some new terminology. All right, so first of all, with reciprocal fractions, you're going to hear me and a lot of other people mention this word flip. Okay, we have to be careful about that, okay, because in Miss Johnson's 12A class, you guys have been looking at flipping graphs over the x-axis and over the y-axis. Those types of flips are called reflections. Okay, so when you reflect a graph, you're just flipping it over a horizontal or vertical line. In this case, okay, we're talking about actually flipping fractions, flipping numbers. Okay, so we're never going to flip a graph over an x or a y-axis in this unit. Okay, so, that actually might come up, all right, but not in this beginning part for sure, all right? So reciprocal functions, what we're looking at below here, we just have some numbers listed here, and what we're going to do is we're going to just find the reciprocal of each number. So if you look at the first one here, you have a fraction of 3 over 4. The reciprocal for that is 4 over 3. Okay, so that's what I'm talking about, flipping fractions. Okay, if you want to get the reciprocal of a number, you literally just flip the fraction over. So the sign doesn't change, all right? It's a positive 3 over 4 becomes a positive 4 over 3. So we're not changing the signs of anything. We're just literally flipping over. So negative 2 over 5, that should become negative 5 over 2. And then you see some whole numbers here. Well, just remember that if you have something like a negative 5, it's really negative 5 over 1. All right, any whole number that you have, any integer number, is really itself over 1. So if we go to flip that, you're really getting negative 1 over 5. And whether the negative goes on top of the fraction, on bottom, or generally in the middle is where you'll see it, it all means the same thing. So positive 4, you flip that over, you get positive 1 over 4. Negative 9, flip that over, and you get negative 1 over 9. So you can see that the positive numbers, the reciprocals of those, are still positive numbers, and the negative numbers, reciprocals of those, are also negative numbers. Now let's pull up a few special cases right here. And what I mean by special cases is, take a look at what happens here. If you have a positive 1, well, positive 1, of course, is 1 over 1. And when you flip 1 over 1, you still get 1 over 1, which is equal to 1. So you could say that the reciprocal of 1 is 1. And then if we take a look at negative 1, same deal, all right? If we have negative 1, you flip that over, and that becomes 1 over negative 1, which is equal to negative 1. So these two numbers right here, these are the only two numbers in the number system where the number and its reciprocal are the same. So that's an important piece of information that we're going to use in this next section. Okay, so we want to hold on to that, all right? The two numbers where if you get the reciprocal of it, they're the same number. That is 1 and negative 1. The reciprocals are the same. Well, what about 0? You can't flip 0 over, can you? Well, you cannot actually. All right, it's a whole number. All right, so let's just put that over 1. If we flip that over, we get 1 divided by 0. And one of the rules of math is that you cannot divide by 0. If you tried it in your calculator, 1 divided by 0, you'll get an error. You can't divide anything by 0. So in that case, all right, we have an undefined solution. Okay, we cannot get the reciprocal of 0. The reciprocal of 0 does not exist. So this is going to be another important thing that we use when we start sketching graphs. So these are the three reciprocal numbers that you really want to pay attention to. Reciprocal of 0, undefined. Reciprocals of 1 and -1 are themselves. And then we also want to keep in mind that the reciprocals of positive numbers are still positive and negative numbers are still negative. Moving along here, okay, this is not reciprocal functions, but it's going to be tied in very shortly. So we want to take a look at something that I believe is brand new. Okay, this term called asymptote. I don't think you have seen this in any of your other math courses. And even if so, we'll just treat it like it's brand new. And an asymptote is, if you look at the diagrams below, they're not really diagrams, they're just graphs, but you can still look at them. And you can see dashed lines. One is horizontal, one is vertical. And then you can see the graphs, they're getting closer and closer to those dashed lines, but they're never actually touching. So the official definition of asymptote is a line. In our case, we're going to stick to just horizontal and vertical. So it's a line such that the distance between the function and the line approaches 0. So the curve, f of x, gets closer and closer to the asymptote, but doesn't actually touch it. So the horizontal asymptotes, if you remember back in grade 10, when you guys were studying linear functions in your numbers course, the memories coming back right away, all right, 2 years ago, horizontal asymptotes, well, we didn't do those then, but we did do horizontal lines, all right? They have a special type of equation. If a line is horizontal, it can be represented with the equation y is equal to whatever number it passes through. So you can see, like on the graph on the left, the horizontal asymptote passes through y is equal to 2. So every point on that asymptote will have a y value of 2. So all horizontal lines are written as y equals a number. And similarly, all vertical lines are written as x is equal to a number. So as we proceed and we have to determine horizontal and vertical asymptotes, you'll always write them as the equation of a horizontal or vertical line. So for all horizontal asymptotes, you'll write y equals a number. And for all vertical asymptotes, you'll write x is equal to a number. And then very quickly, all right, you don't necessarily have to copy this down, but this is just a random graph. It's actually not random, it's very deliberate, but it's something that you haven't seen before. All right, so you're not expected to know how to graph this. But one thing that you notice here is that in purple and blue, I have in dashed lines that represent asymptotes. The horizontal asymptote in blue is y is equal to 4. The vertical asymptote is in purple, x is equal to 3. And you can see that these are horizontal and vertical lines that this curve in black keeps converging towards, but doesn't actually touch. And then as you move on, you say, okay, well, it's going to pass through at some point. But if you zoom in on it, you see that they don't actually touch. Right? And you can keep going with this. You can just keep looking at this and still doesn't touch. It just gets closer and closer and closer. So one thing you'll notice here is horizontal and vertical asymptotes definitely going to be used on a regular basis over the next few weeks. All right, let's get started with actually sketching reciprocal functions.